Mr. Jung at Math with Joy. In this video, you'll be learning how to perform a two-sample t-test for the difference in population means. What parameter do you want to estimate? At what significance level? I want to estimate the difference in population means, where the first population mean is the mean GPA of all male students at a made-up high school, and the second population mean is the mean GPA of all female students at this made-up high school by performing a test of the following hypotheses using the significance level of 0.05. What is the claim you want to weigh evidence against? State the null hypothesis, also known as the statement of no difference. The null hypothesis is that the difference in population means is 0. Another way you can state this is by saying the mean GPA of all male students is equal to the mean GPA of all female students. What is the claim you are trying to find evidence for? State the alternative hypothesis. The alternative hypothesis is that the difference in the means is greater than 0. In other words, the mean GPA of all male students is greater than the mean GPA of all female students. Please note that this data is just made up. What is the name of the inference method? What are its conditions? I will be performing a two-sample t-test for the difference in population means. In order to make an inference about the difference between parameters regarding two populations, data must come from two independent random samples or from two groups in a randomized experiment. Data in this study comes from two independent simple random samples, so this condition is met. The formula for estimating the standard deviation of the statistic, also known as standard error, is correct if both samples are selected from infinite populations or with replacement from finite populations. Or, if sampling without replacement, the sample size must be less than or equal to 1/10 or 10% of the population size. This must be true of both samples and their respective populations. The sample sizes are 50 and 40 respectively. It is safe to assume that these sample sizes are less than 10%, less than or equal to 10% of their respective population sizes. So this condition is also met. The standard error estimates how far the difference in sample means will be from the difference in population means on average in many random samples or assignments in randomized experiments. Using the formula for standard error, we get approximately 0.18841144646. Constructing confidence intervals involves normal calculations. We can use normal calculations if both sample sizes are at least 30, or if either sample 1 or 2 is less than 30, the sample distribution does not show strong skewness or outliers. In this study, both sample sizes are at least 30, so this condition is also met. Now, we're actually not doing normal calculations here. We're doing t-distribution calculations. The t-distribution becomes more normal the greater the sample size. How do you perform a significance test using a calculator? Using two-sample t-test and the inputs listed below, the calculator generates the p-value of approximately 0.044. Make sure you set the pooled option to no. The test statistic is approximately 1.725. This is the t value, t critical value. The degree of freedom is 85.06. Now we're doing a one-sided test. We want evidence to support that the mean of population 1 is greater than the mean of population 2. Our sample statistic was 0.325, which is 1.725 standard errors above our point estimate. Well, how likely or what is the probability of getting a sample statistic that is 1.725 standard errors above or greater just by chance? Well, we're doing a t-distribution calculation, so we can use a t-CDF function in the calculator, and using the lower upper bounds 1.725 and 10,000 respectively, and a degree of freedom 85.06, we get a p-value of approximately 0.44, which matches the calculator output. How do you interpret the p-value? Again, assuming that the null hypothesis is true, there is a 0.044 probability of getting a sample statistic, which is the difference in sample means, of 0.325 or greater just by chance from two independent random samples or groups in a randomized experiment. How do you perform a significance test using the given formulas? The standard deviation of statistic formula is given to you on the exam, and we already calculated it. It's approximately 0.188. When you don't have a calculator, the degree of freedom is the smaller of one less than either sample size. So the conservative estimate of degree of freedom is 39. Now we're going to use the degree of freedom of approximately 85.06 that's calculated by the calculator for the remainder of the calculations here. The formula for standardized test statistics is also provided on the AP exam. The parameter is going to be 0 here because in our null hypothesis, we stated that the difference in the population means is equal to 0. That will be our parameter. The statistic, which describes our sample sizes, or rather the sample statistics, is going to be the difference in our sample means, which is 0.325. The standard deviation of statistic is the standard error, which we calculated to be approximately 0.188. Plugging in these numbers into the formula, we get 0.325 minus 0 over 0.188, which is approximately 1.72. This is the test statistic, which is the t-critical value. Well, we already did this in the previous slide, but the probability of getting a value, a t-critical value of 1.72 or greater, can be calculated using the t cumulative density function. Our lower bound is 1.72. Our upper bound can be any large number. I'll plug in 10,000, 100,000. The degree of freedom that's calculated, that's given to us by the calculator is 85.06. It comes out to approximately 0.044. Actually, I think it comes out to 0.0445, which is in line with what we got using the two-sample t-test function of 0.044. What can you conclude? Because the p-value of approximately 0.044 is less than the significance level of 0.05, we reject the null hypothesis. We have significant evidence that the true mean GPA of male AP students at this made-up high school is greater than the true mean GPA of female AP students. What error is possible from this conclusion? A type 1 error is possible because we rejected the null hypothesis. The null hypothesis might actually be true. There may not be a difference